Chapter 9, Statistics and Probability. 9.1, Collecting Data. This chapter starts off, we're talking about ways that mathematicians collect data and put them into groups and start to use that information. So the first thing we're starting off with is types of data. And we've got three types of data. Categorical data deals with groups. It's when we put things into groups or categories such as eye colour, favourite fruit. It goes into an actual category. The next two, discrete and continuous, deal with numbers. Discrete data we actually count, and it's typically a whole number. So for example, number of runs scored, number of points scored in a sports game, that type of thing. Continuous data is data that we tend to measure. It can be a decimal or a fraction. So height and weight are the two examples I've got there. You can have half a centimetre, for example, when you're measuring height, right? But typically with discrete data, we're dealing with the whole numbers. So for example, you are 12 years old until you turn 13, and so on. So it's a discrete category. All right, worked example 1. For each of the following, state whether the data from a survey asking these questions is categorical, discrete, or continuous. So we're just classifying it. So, the number of television sets. So we're actually counting how many television sets we have, and it's typically a whole number. You don't have half a television set, so that is discrete. The height of the tallest in your family. Well, you'd measure how high somebody is, and it can be a decimal number, so that would be continuous. How far you travel to school. Once again, you'd measure the distance that you travel to school, so it's continuous. That's an abbreviation for continuous. And your favourite dessert. Well, we don't measure what your favourite dessert is. It doesn't come as a number. We actually name what the dessert is. So it's an actual category, so it's categorical. And that's how we complete these questions. Frequency tables. What mathematicians often do is put the data that we collect from such surveys into tables like this one called frequency tables. We start with the actual data that we're collecting, which is often referred to as X. And these are the things that whatever it is we're measuring. So perhaps we're counting the number of brothers and sisters you have. You can have 0, 1, 2, and so on. The tally column is typically used as you enter the information in here. You read off the data when you put a little stroke in there for each one, and so on. And then you add it all up at the end. So we've got 0's got 4, so we have 4. 1 has 5, so we've got a 5 over here. 2, we have 2. And we can total this column up for a total down the bottom here. So 4 plus 5 is 9, plus 2 is 11. So this column here we refer to as our frequency, or how many. So how many of the responses were 0? There was 4. How many were 1? There was 5, and so on. And it totals up, we had 11 responses in total. So let's look at an example of how this works. So we can think of this as our actual score or our value, our data that we're surveying. We tally it up as we go, and the frequency is how many of those responses did we get. Alright, worked example 2, where we've actually got to do this. A class of Year 7 students, or 25 students, was surveyed around the number of brothers and sisters they have. And these were the results. So the number of brothers and sisters, or the number of siblings. And here's the one. So the first person we surveyed had 2 brothers or sisters, 3 and 5, that must be a big family. This person was an only child. So these are the actual results we got from our survey. 2 things we've got to do. Construct a frequency table, which I've started to do down here. And is the data categorical, discrete, or continuous? All right. Okay, so you'd rule up a table just like this. The first column is what we're actually surveying. We're surveying the number of brothers or sisters, or siblings, it means the same thing. So, we ask ourselves, what's the lowest result that we recorded? So we've got some zeros, and what's the highest? There's a 3, there's a 5, there's nothing else above 5. So all of our responses are between 0 and 5. And that's what we put in this column here. 0, 1, 2, 3, 4, 5. Okay, now we tally it up. So to do that, we run through our data. So there was a 2, so we put a little mark in there. There was a 3, there was a 5, there was a 0, a 1, another 1, a 2, a 0, a 3, a 1, oops, my mistake, that one goes there, a 4, a 0, that's that one there, a 1, another 1. When we get 4 marks, we cross it off so it's 5, so it's easier to read it off. A 3, a 2, a 2, another 2, a 1, another 1. You can see I'm starting another group of 5 here. A 0, a 1, a 1, a 2, and a 4. Okay, so to complete our table, we simply add these up, get our frequency column. Remember, F is frequency. So there's 4 marks there. So there were 4 responses. 4 people surveyed had no brothers or sisters. 5 and 4 is 9. 9 of the people surveyed had either one brother or sister. 5 and 1 is 6. Had 2 brothers and sisters. 3 people had 3. 2 people had 4. And 1 person had 5. And if we add these up, it should equal 25, because our question from the textbook told us that there were 25 people surveyed. We add these numbers up, we get 25. There's our frequency distribution table. Okay, the next part of the question, is the data categorical, discrete, or continuous? Well, we're not putting things into categories. All right, we're using numbers. Our responses are in actual numbers, so it's not categorical. So is it discrete or continuous? Are we dealing with whole numbers, or do we have decimals? We're dealing with whole numbers because you can't have half a brother or sister, all right, as opposed to a half brother. You can't have half a brother. It's a whole person, so it must be discrete. Not continuous, not categorical. Grouped data. Often what mathematicians will do is group data together, and there's certain ways that we do that. Now, a bit of terminology. The range. It's a measure of the spread of the data, how widely spread the actual data is. The range is calculated by getting the biggest value and subtracting the smallest value. We can group our data together. Typically when we group our data together, we want somewhere between 5 and 10 groups. And I'll show you that in our next example. The class interval is what we refer to as the size of each group. And this is the information that we'll put in our first column of our frequency table. So if we're dealing with discrete data, say we surveyed people and responses were between 0 and 29, for example, we're grouping 0 to 9 together. So all those responses go together. 10 to 19 we're grouping together, 20 to 29 and so on. Alright, it's discrete data, they're whole numbers. Continuous data is a little bit different. We're grouping it from 0 to less than 10. So let's suppose we're talking about the height of certain objects or the length of certain objects. So up to less than 10, so that's 9.999 recurring in that range. This range from 10 up to less than 19. So the next group would be 20 to less than 29 and so on. And these are the things that we write in our first column of our frequency table. Alright, worked example 3. The exceptional Felines basketball team keeps track of points as they score on the way to the state championship. The total points are, and they're listed in the textbook. Group these results and then construct a frequency table showing this information. Okay, now first thing we've got to do is pick how big these groups are going to be. We typically can just have a guess and see if we get it right, or we can actually do it mathematically. It's probably easier to use this method rather than this one down here, depending on how big your data is. If we have a look at our actual data from the book here, we look at our lowest numbers. We've got a 40 in there, and there's nothing below the 40. There's some 41s, but 40 is the lowest number we've got. And the biggest number is, what have we got? We've got an 81 in there, 83 in there. That's about the biggest number. So there's our spread of the data. It's between 40 and 83. So you can just guess and say, look, I want sort of about 5 numbers per group. So 40 to 44, 45 to 49, 50 to 59. That's a mistake. And so on. Or you can think about this mathematically. All right, let's have a look at our range. 84 was our biggest number on there, 40 was our smallest, so we've got a range of 44. If we want an interval size of about 5, 44 divided by 5 equals 8.8. Round that off, so that means we'll end up with about 9 groups. So I'm doing the same thing in both of these. I'm just working out mathematically that if I want my interval size of 5, 40 to 44 is 5, I'm going to end up with about 9 groups. So what does that actually look like? 40 to 44, 45 to 49, and so on, right through to 84 at the end there. Okay, so this here forms the first column of our frequency table. Now when we look at the actual, we'll draw up a table around this, like this. This becomes our scores. We do a tally column, and there will be a frequency column, and so on. We go through the list of numbers in the textbook there that we've actually surveyed, that we actually recorded from the basketball games, and we just start putting in the tallies. The first number is a 73, that's in this group here, so we put a little mark there. The next one's 84, that's in that category there. The next one's 68, that's in that group there. The next one's 45, fits in that one there. And you keep going until you've gone through all the data. What you end up with is something just like that. Here's our first column, looks just like the list I had. I went through and I tallied them all up as we went and added up my frequencies. 7, 3, 3, and so on. There were no points scored in here, so there's no tallies in there, so it's a 0. And it should all add up to the number of actual games that they played, which is the number of scores that we actually recorded, which is 40.